Okay, hi there, and welcome to another update on the volcanic eruption in Iceland. I'm geology professor Shawn Willsey. Today is Friday, August 30th. It's about 10 a.m. Mountain Time and 4 p.m. over in Iceland. As you can see from the webcam view here, it's a foggy day on the Reykjanes, and so the only webcam that's showing us the active eruption in its full splendor is this view from the east, the Sandhole area, looking to the west, and you can see the sort of construct here, this accumulation of lava and spatter that has been built up over the last week or so. We're now, I guess, on day 8, I suppose, of this eruption. Does look like the fountaining at the vents here. There's two vents, adjacent vents that are still active, and the fountaining seems to have died down a little bit in terms of its intensity. It's not quite as vigorous as it was the last few days. At least that's just based on me viewing this for a few minutes this morning. Might be wrong there. Might just be pulsating a little bit. But it seems like it's possibly slowing down a little bit in its vigor. We're going to run through several things today, go over all the latest data, talk a little bit about the air quality, new some information that came out with some of the samples that they've collected from this eruption site over the past week. And then we'll look at kind of the future and what we might be looking at in the long term here in this area. One more webcam view just so you can see how socked in it is on other webcams that are a little bit more distant. And let's just go ahead and start with our first Met Office update. As always, thanks to Amanda Joe, who's sent me a tremendous amount of data and information that I was able to use to put this update together. So we're going to go over several things here on this Met Office update, but let's just start with a couple things here. This actually came out yesterday evening on the 29th. So the main thing here out of the Met Office is that the output of lava from the volcanic vent where the eruption is occurring is still seems to be exceeding the actual inflow of magma into the storage system in the subsurface. And we can see that based on the GPS data. It's still showing maybe a slight downward trend. Maybe it's starting to plateau and level off a little bit, but I'll show you in a minute here that it's tracking very nicely and showing very similar behavior to the May 29th eruptive event. So eruption's pretty stable over the last few days. The lava flows that are coming that these vents are feeding have advanced a little bit to the northwest and to the east, but not substantially, and they're not threatening any sort of infrastructure or anything. And there's a little bit of earthquake activity to discuss. It's showing a little bit more seismic activity than in other eruptions, and we'll get to that here in a second. Let's first talk about the gases and the wind first. And so make this a little better size here. And so you can see this is the Met Office's forecast for currently and for the rest of the weekend. You can see the point source here where the vent is, and these south winds just basically carrying that plume of sulfur dioxide and those volcanic gases due north, which would seem to be great, except for just along the coast due north of the eruption site is the town of Vogar. So the air quality for that specific location is quite low, along with that little section of the roadway there. And so you can see that's unlikely to change over the next few hours going into tomorrow. Kind of persistent south, maybe southeasterly winds at least for the first part of the weekend. And switching to an air quality map here, you can see green dots and other places are showing good air quality. The eruption site's somewhere about here, and you can see Vogar right there has very poor air quality. And if we throw that up on a graph here, this is over time. So you can see today's the 30th. I said it's about 4 o'clock or so there. So this is up to the last hour or so. So you can see over the last few hours, maybe the last 4 hours or so, they've gone into the red in terms of the concentration of sulfur dioxide in the area there. So not a good place to be for today, and probably best to stay indoors or maybe get to some other area for a part of the day if possible. So a little bit there on the air quality. Continuing on with the Met Office update, they have a nice little satellite image here showing the extent of the lava flow. So let me kind of cue you in onto what you're seeing here. The actual vent here is down at the bottom. You can't quite see it there. And they've got this on a loop. It's basically, I think, 3 or 4 images from the satellite. The main thing to look at here, here's Lilla Skogfelt, this hill off to the northwest of the eruption site. But the places where you can really see the lava flow advancing are right here around this lobe, on this lobe where it expands out. So here's the first frame, second one, third, fourth. Yeah, so it looks like we got 4 images here. This linear feature here is a large fracture or crack system. And so maybe to show you what that looks like on this map here, it's this linear part up here at the far north end of the map. So that's essentially what we're seeing. So what we're seeing is the expansion of this northernmost flow to the northwest. That's one of the primary things you can see there. So kind of going back to that. So again, there's that linear edge to the flow, and then there's the flow field expanding to the northwest. You can also see at the other end of this fissure, you can see a little bit of expansion and a little finger of lava that's expanding to the northwest over here as well. And so that would correspond with this end here. We've got a little bit of the lava that's seeping out and coming out along this little pathway over here. So they've got that, which is kind of fun. And going back to the main Met Office update, they talk here about seismicity and earthquakes since the August 22nd eruption being a little bit higher than what we've seen in previous eruptions. Their explanation here is that it's probably because the eruption, now I'm quoting, the eruption is now taking place further north where more tension is still within the bedrock, whereas tension has been released significantly further south than previous events. And I think that makes sense. You've introduced a new stress regime into this region because of this magma influx and the eruption itself. And so you're probably getting a little adjustments in the stress field with those rocks, and that's what's generating a lot of the smaller earthquakes there. And we'll look at the earthquakes here in a second. About 20 earthquakes for the past 24 hours and about 110 for this week since Monday. Land subsidence. So this is an interesting graph here. Let me switch to a bigger view of this graph. What we have here, the green dots and curve, is our May 29th eruption. So from May 29th all the way through June, July, and all the way up to, I guess, August 21st, the day before this last eruption occurred. This would be our GPS. You can see it initially dropped for a good part of a week or so before it started to kind of level off. Then it started to pick up, and then it was a good, gosh, almost 3 months, 2.5 months at least, of steady inflation, more or less steady inflation, that culminated with this last eruption. And if you look in here in red, that's the current state where we're at now since this August 22nd eruption. So we're only a week or so into this thing, but look how closely it's tracking and largely mirroring and paralleling this last set of data from the May 29th eruption. So we'll see if that holds true or not, may or may not. But I guess the behavior that we're seeing with the continued deflation, which might be ending quite soon if it hasn't already, is not to be surprising because we've seen that behavior in the past. And then they talk a little bit about the gases, which we covered. And then there's a new hazard map. And usually I don't spend a whole lot of time on these because a lot of times they're largely unchanged. But the significant thing here is Zone 1, which is the Blue Lagoon and Power Plant, has dropped down to a lower hazard level, the moderate category, primarily because the active part of the vent is too far to the north to impact this region with lava flows or tephra or anything like that. And so what they've done here is dropped the level here and then expanded. They've kind of added this little dash zone over here because we know based on that satellite imagery that we have lava flows that have extended beyond the prescribed areas here. So they're probably going to continue to need to modify the size and shape of these hazard zones moving forward. But that's the whole point of a hazard map: continually update it, modify it as needed as the conditions change and the variables change. So that's pretty much it, I believe, for the Met Office update, for at least the last update they put together. Let's jump over now to the earthquakes that we've seen in the region over the past 24 hours. We'll dump in all the tiny earthquakes for kicks. And there you can see mainly again concentrated right around this new eruption site where this new fissure opened up. And I would agree with the Met Office that this likely represents you've created a new conduit in the system that we haven't seen previously. Most of the other previous eruptions followed similar or the same pathways. And so we're just seeing some adjustments here. Mostly small quakes. I think there's one in there that might be over magnitude 1. Yeah, 1.5. But by and large, very small earthquakes. I believe most of them are fairly deep. Yeah, 5 kilometers, 6. Another 6 there. So nothing much to worry about there. Just random noise going on over here to the east towards Fagradalsfjall, nothing indicative. And these are quite deep as well. These are 6, 7s. I think there was even 8. Yeah, there's an 8 right there. So just normal behavior on a plate boundary. One fun event that happened early this morning that, and I was interested to see that I don't know if the Met Office seismometers don't extend that far or exactly what's going on, but basically I can't even keep the map in the right spot. But if you look at the bottom end of the map here, where the Mid-Atlantic Ridge, where the ridge comes off of the Reykjanes Peninsula, then makes a big zigzag movement, sideways movement there, right, more or less in the middle of your screen. We did have an earthquake there today that was picked up by the USGS system, and so it was big enough that we could detect it with our seismic networks here in America. So it was a 5.6, right, located right here, right along the plate boundary, right where there's a fairly substantially long transform or strike slip fault, side to side movement here. Again, not related to magma movement at all, and certainly not related to anything going on with the eruption on the Reykjanes. If you look at that earthquake in detail, we can see the beach ball here, the fault plane solution, and this pattern indicates that it indeed was a strike slip fault, a side-to-side motion on this fault that produced that earthquake. So I thought that was kind of just fun. I got that in my email notifications that there was this earthquake far south of Iceland, and found it interesting that it's somehow off the Iceland seismic network, at least what they show on these ones. But if we just zoom in the last week or so, so this shows everything after the eruption. This doesn't show all the fun activity that was taking place on August 22nd when the eruption began, but you can see everything just well confined and constrained to the eruption area and that new fissure that opened up. So that's where all the action is. That's the new conduit that's opened up, and so we're seeing higher than normal seismic activity here, solely and most likely because this is a new section of crust that's been ripped open and is providing a conduit for the magma to flow through it. So it's still producing quite a bit of seismic energy, as opposed to this longer system down here, which has served as the primary magma conduit for past eruptions, and largely doesn't have a whole lot of seismic energy going on here because those pathways are already established. So earthquakes, if we go to GPS for a second and just check out and just maybe confirm what the Met Office data was showing us there. We can start with the 8-hour data, and then we can go to the 4-hour data, I suppose. So here's our Svartsengi station. Not that this is the best one, but we believe it's the closest. Let me get my big fat face out of the way. There we go. And you can see here where it's starting to tail off. There's the eruption right there. So the elevation of this GPS station dropped considerably as the magma started escaping the ground and coming to the surface. And since then, for a week now, we've been seeing more or less deflation, but you could make a reasonable argument that the last 4, 5, 6 data points here might show it starting to level off a little bit, that the downward trend may be over. If we switch over to the 4-hour run, so collecting data points from that station every 4 hours rather than 8 hours, you might even be able to convince yourself that not only has it started to maybe level off, realizing there's some error bars here. Probably leveling off would be as far as I would take it, but I wouldn't totally shake my head and give someone a stink eye if they told me it maybe was starting to uptick just a little bit. Well, we'll have to see moving forward. Next couple days will be interesting to see if we start to see more of an inflationary trend in that data in the days to come. So GPS data, there's no new interferograms, no INSAR data to show you. The satellites might pass over sometime in the next few days, so I'll be sure to share those with you at that point. And the next thing I want to cover is a article and some analyses from the first samples that they've looked at from this eruption. So they went out and collected samples of this lava on, it says, the second and third day of the eruption, and on the fourth day they got a sample as well, north of Stora Stogafelt, so at the northern end of the fissure system. These were analyzed in Iceland, and it says the samples all are very similar to previous samples from eruptions since December 2023, contain vesicular glass with plagioclase, olivine, and this probably is augite, the mineral augite. And I think instead of dikes, I think the translation here is they mean is crystals. That's just my take on it. The rapidly cooled lava samples have a lot of microcrystals, but the pyroxenes are crystal poor. So what you can see in this image here, and I can't seem to blow this up any larger, so I apologize, but a photomicrograph of the crystals in the lava. So there's a big crystal plagioclase showing that characteristic 90-degree cleavage right there, that right angle. Another piece of it right there, that needle at the very bottom. And then in these lighter grays, it might be a little hard to make out, are some olivine crystals. And then this is a different sample, a more gas-rich sample, and these big black circles are the gas bubbles or the vesicles. And you can see some of the crystals in between some of those. You can see some of these plagioclase crystals and some of these other minerals in there. So concentrations, they talk about a little bit about the concentrations, different materials, but the whole point here is it basically the magma production and magma accumulation deep under the peninsula is evolving into a more stable state with less variation in composition. So the whole thing is becoming a little bit more homogeneous. The magma it seems to have thoroughly mixed with maybe the deeper source, and so things are looking very similar eruption to eruption. That can change, and so I'm sure they'll keep sampling these lavas moving forward, but pretty interesting nonetheless. So some geochemistry analyses there. So good work from those folks. And then the last thing I want to cover here, looking forward. Oh, I got to show you a couple photos that, so Amanda Jo actually went out to the viewing area near the eruption site, and she's a photographer and sent me this great photo she took with kind of some nice effects and filtering going on here. She also took some other photos during some of her recent trips in Iceland. I guess I'll show a few of these. She said I could take them or leave them, but she is a really talented photographer. I think she would cringe if she heard me say that, but just so you can see some of the great work she did. This is, I believe, out at Jokosodan, the glacier lagoon. We've got probably the same place here. Just a couple pictures that she sent me. How come this one's not loading? There it is, one with the birds. And I think that's it. And then she did show me where she went to watch the eruption. So maybe I'll show you this on Google Earth. That might make more sense. So basically, just off the main road here, there's a lake right here. So this is the turnoff to the Blue Lagoon and Grindavik. And there's this sort of secondary gravel road right here. And it appears that they let people park along this and watch the eruption site. So the eruption would be more or less over here. So you're watching it over a distance of several kilometers, but that's the place that you might be able to look and see the eruption taking place. But probably not a good idea to do it today, because remember the volcanic gases that are going on today. So not a good idea, at least the next 2 days, I would say, at least for this early part of this weekend, to head out there and look and try to look. The sulfur dioxide concentrations could be really high and not a healthy situation. The last thing I wanted to focus on here, team, with this update is looking forward a little bit with the future and what might we expect moving forward. I've given this some thought. I don't have a lot of really good, solid answers, I suppose, and I know I'm positive these discussions are happening with public officials and scientists in Iceland, but I haven't seen any articles or news stories coming out yet. But it'll be interesting to see moving forward, now that our focus seems to have shifted, at least temporarily, from protecting these areas here. We've spent the better part of a year protecting the town, protecting the Blue Lagoon and the power plant, building these defensive berms, They have a very efficient and effective evacuation system in place now. In fact, it's so streamlined that we can get people out of the Blue Lagoon, let the eruption begin, and people can basically be back in the Blue Lagoon within 24 hours, depending on how things go. That certainly was the case with this last eruption. But with this last eruption, I think the equation in the game has changed a little bit. With this eruption occurring much further north, which is great news for Grindavik and the power plant area, I think the focus needs to turn to the infrastructure that's located to the north. We know that there's lava flows advancing even as we speak to the northwest. We don't expect those to go very far. There's lots of room, lots of real estate here for those flows to fan out in. But what about the next eruption? What if the next eruption isn't here, but maybe 2 or 3 kilometers further northeast? Or what if it steps over? We've seen these fissure systems have like a step over, what we call an en echelon movement, and you can see there's these existing fracture systems, these weak zones. Those are just at the surface. We don't know how far those extend into the subsurface, but it is possible for the next vent to not be a linear progression or continuation of the fissure that we see now. It could actually step over to one of these other systems here, which would place it much closer to the road. This is Reykjanesbrut. This is the main highway from the airport over to the capital area. This, I believe, is Iceland's busiest highway, just in terms of the amount of cars that travel this every day, all the taxis and tour buses and shuttle buses and rental cars. So this, I think, presents a pretty formidable challenge. We've shown the ability to protect, as best we can, a single area, right? So the town, the power plant Blue Lagoon area, by surrounding it with defensive berms and then also using the topographic features, the large hills, the coastline, to keep the lava at bay as best we can. But how do you protect a long, continuous roadway that is more or less perpendicular to the likely flow path of one of these lava flows? I would expect the lava to move across this area like this. So even if you protect one section of the roadway, how do you protect all sections of this roadway? And I'm no engineer here. I don't know exactly, could you build like an overpass, like a bridge, and channelize the lava and allow it to go under? Is that too much heat for the structural materials? I don't know. And obviously building something like that would be a much bigger undertaking than possibly the defensive berms we've seen in the past. So I did, just for kicks, draw just a possible, if you did try to put some defensive berms around this town, Vogar, you could build something like this. But the roadway, I was a little flummoxed on exactly how you would deal with that. The other issue here is, there's the town, so maybe we can protect this infrastructure, but as you move along the coast to the east, there's all sorts of little homes in here. Here's a little cluster of homes, some sort of business or something in here, more homes along the coast, and these continue for some distance going towards the capital area. So how, making those decisions of what to protect with these defensive measures, if we go with some sort of structural situation like we have here, it's very tricky. And so I know they'll make the best decision they can, but it's a challenging thing to consider, but one that I think needs to be discussed soon, and I'm sure they are discussing it at this point. I am hoping I did hear back from him. Professor Thordarson has agreed to do another interview with me, so I'm hoping to do that in the next week or two, and I'm interested to hear his thoughts on this as well. Maybe he's already had discussions with some of these public officials, so I'm interested to hear what plans they have in place for protecting these areas in the event that this eruption continues and maybe this lava flow gets closer, or more likely there's the next eruptive event. And it is interesting that looking at the Fagradalsfjall eruptions, they progressively moved north. Again, just 3 data points, not convincing. And with our 7 eruptions we've had here, it's kind of moved around a little bit, but we've ended, at least most recently, on this northernmost point. So it'll be interesting to see how the next eruptive events play out and where exactly the location of those is. Because this one started out well behaved. The primary eruption site was right in here, right where we predicted it to be, right in the area that had been erupting the most previously, but then it quickly focused its intensity up at the northern end, ripped open a new section of the crust here, a new fissure system, and that's where we're seeing the eruption taking place now. So just for some food for thought, some things that I've been thinking about as I've considered this. For now, things are in pretty good situation. The eruption took place in as ideal an area as you could ask for, given the current state of affairs and where things are located. But it does present some room for concern moving forward. So I'll leave you with that. Thank you as always for your support of the channel, for watching and sharing and learning with me. Super appreciate you. Have a great weekend, and we will see you next time. Take care.